Okay, great. So welcome everybody, and nothing like flying by the seat of your pants. Flying by the seat of your pants. We're going to show you something that usually is done, I guess, in about 6 hours. We're going to try to compress it in 1 hour, but hey, we're going to have fun. So this is going to be actually a way for us to take a look at using our micro-learning series and take a look at how you can go to using machine prediction or using machine learning to go from zero, like awareness of how this machine learning stuff works, into actually doing prediction on something. We're going to use something called mall customers data set. We'll explain that in a second. I'm not expecting that you're going to become experts. You shouldn't expect that you will be experts either. It'd be too much to ask. However, the intention and the objective of the micro learning series is to get you to understand how this whole thing comes together, why we use it, and then show you a demo where you can actually use your favorite large language model to further kind of discover and learn what is possible with machine learning, and in this case, going to be linear regression is what we're going to look at. All good to proceed? You can just ask your questions. I think Hazar can chime in and help me as I'm going to be going through some slides. There's going to be some kind of fundamental level setting on machine learning, and just talking about the different supervised and supervised learning, and then we'll see what questions you have, and then we'll quickly do a quick jiu-jitsu flip and jump into an actual suite that you have access to, available from Google for free, called Google Colab, and we'll look at Kaggle as well for data sets. And you can play with all of these things after the series, after this session. And please use the Academy, and Hazar, I believe, will have this session kind of under Learning Commons or somewhere. Maybe she can announce it, where you can actually create a discussion thread. You can start asking further questions, and I'll do my best to try to be timely in responding to these questions. Now, I've actually, some of these slides I just built like literally a few minutes ago, so hopefully there's no mistakes, but anyway, we'll catch them. But I think that to me, I love concepts that are simple to grasp, simple to explain, and they're just like, oh, okay, well, that makes sense, because then you've actually been able to kind of boil something down to the most fundamental elements, and you understand it well to be able to explain it. So I'm going to take a shot at explaining traditional programming versus machine learning, and what is the difference between the two, and what would you do, which let's say pattern or which type would you use for what kind of use case that you are applying, right? So, and I think this is really the starting point in explaining. If we're going to be talking about machine learning and trying to get you to start thinking about algorithms and AI and all that stuff. I did an earlier session, and I see Ken is here. It's good to see you again, Ken. Earlier this morning, we did a session at UNC where we were talking about using generative AI for creative output. So this would be different modalities. We looked at different modalities. We focused on text, but we showed video and image generation. There's also music generation now. There's just so many things that are generative AI is able to do for us and create new content for us. But all of it comes from, again, some kind of a machine learning, right? And the generative AI is kind of like the progression, or let's just say the latest model, or the latest how would you say it? Like the latest discipline in using a lot of what we've done in AI over the past decades, and using neural networks that have been trained on a lot of data to start helping us create new content. Now, with this, what I'm about to show you is we're taking a bit of a step back, and we're not necessarily in like the advancements or the technology. No, we're taking a step back from generative AI and saying, all right, I actually want to look at applying AI to real use cases. I'm not necessarily generating new like text or image or whatever, but I want to be able to interpret the data, and I want to be able to build a machine that can predict certain values for me. So this kind of discipline of AI, which got started in neural networks in the early 80s and onwards, and just kind of evolved to machine learning in the 90s and the 2000s. The distinction between the two is these two blocks, and I try to kind of just boil it down and just make it as simple as I can in the explanation so that we can get the message across. And please ask questions in the chat. I have the chat open. We're not going to move off this slide until you get it. So if we look at traditional programming, and you can think of traditional programming as any application that you currently use that is, let's park the chat GPT and all that stuff for a second. Any traditional programming that you currently use, weather applications, let's say Microsoft Word, Microsoft PowerPoint, there's an already defined set of, there's an actual programmer or code that has been written where it will take data and it will operate on that data and it will give you some kind of an output. So that's traditional programming. You have pre-designed or a prescribed program, rules, lines of code that take data, and then they will give you an output based on the rules and the branching and the tree that you go through on that data that you provided to the program, and you will get that output. So that's traditional programming, and that's what, I mean, until today, there's still traditional programming. When we write code, whether it's JavaScript or Python or whatever your poison is, you're writing a set of codes. These code take data, new data, and they give you that output. Now, machine learning, on the other hand, is different because machine learning starts with data, and it looks at data and output, meaning like we kind of create what's known as labeled data. So we say, oh, this is data and this is good. This is data, this is bad. This is data, this is like, I'm not really sure. So you actually start labeling that data. And don't think of data as one element or one variable. Think of it could be multiple variables. It could be hundreds or thousands or millions of different data like output that you create, labeled data. But let's just stay in the conceptual stage right now to say that if I can label that data to say, this is good, this is bad, right? Then I give that data to a training algorithm, which we're going to talk about here in a second, the different types of training algorithms. Then the result is an algorithm, right? So what I end up with is an algorithm that can actually operate on future data that comes in and does some kind of a prediction based on the training it has received.